Okay, so we drew all the triangles inside of the unit circle. We understand reference angles now. So we know, for example, that 210 degrees is the same thing as a 30-degree reference angle in quadrant 3. And so the coordinates would be the same as a normal 30-degree 30-degree angle, like for x and y, except we'd have the x and y values both be negative because 210 degrees is in quadrant 3. So let's put this into practice now, right? And my advice is when you're trying to come up with values on a unit circle is to first of all not memorize it. Okay, don't memorize it. Focus on understanding just the first quadrant, and then once you're given an angle, so for this example, we're given 150 degrees, and we'll do that in a second. We want to draw that angle and then understand what the reference angle is that it's talking about. Write down what the coordinates would be, and then if it's asking for sine, put that y value. If it's asking for cosine, put the x value. If it's asking for tangent, divide y by x. Or if you kind of over time sort of memorize, okay, you memorize how tangent works, you kind of can just write it and then adjust the sign depending where it is. So, for example, 150 degrees. So what I would say is like, okay, 150 degrees, I know that's over here. It would look like a 30-degree reference angle in quadrant 2, right? This is quadrant 2 over here. So a 30-degree reference angle in quadrant 2, I know that the coordinates over there should be negative root 3 over 2 and 1/2. And since I'm asking for cosine, that's the x value, so the answer to this is negative root 3 divided by 2. Let's try another example. Okay, I want to know what's the sine of 30 degrees. Boom, right away, that's already in my first quadrant. That should be one of the ones I know. So a 30-degree angle, it's root 3 over 2, comma 1/2. I'm asking for the y value because it's sine, so the answer is just 1/2. That's it. Let's try another one. Sine of 330 degrees. Okay, so 330 degrees would go all the way. We'd be in quadrant 4. We'd have a 30-degree angle there because that would make 360. So the coordinates here are going to be those same coordinates, root 3 over 2 and 1/2, except the 1/2 is going to be negative, and I'm asking for the y value, so this would be just negative 1/2. Let's try another one. And I encourage you to, as we go through some of these, there's 8 more, or 6 more, or 7 more, pause the video before I start answering it and see if you can figure it out for yourself. Okay, pause the video. The sine of 210 degrees. 210 degrees is going to be over here. It's a 30-degree reference angle in quadrant 3. So again, the coordinates for a 30-degree reference angle are root 3 over 2 and 1/2, except we're in quadrant 4, so both of these are negative, and I'm asking for sine, and so it's going to be negative 1/2. The last one was negative 1/2. Okay, so tangent of 210 degrees, we'd have 210 degrees is in quadrant 3. It's a 30-degree reference angle there in quadrant 3. I know that the tangent of 30-degree reference angles is root 3 over 3. But since it's in quadrant 3 down here, the coordinates would be negative root 3 over 2, comma 1/2, negative 1/2. It'd be a negative divided by a negative, and we'd have a positive. So the answer would be root 3 over 3. Again, we can do that. Y over x, negative 1/2 divided by negative root 3 over 2. That's the same thing as 1/2, negative 1/2 times negative 2 over root 3. 2's cancel. This is positive now, 1 over root 3, and rationalize it. You'll get root 3 over 3. Ooh, tangent of 135 degrees. Okay, tangent of 135 degrees, that'd be a 45-degree reference angle here in quadrant 2. The coordinates here are negative root 2 over 2 and root 2 over 2. That's a 2. So this is like something divided by negative itself, but this is just going to be negative 1. The tangent of 135 degrees is negative 1. Cosine of 300 degrees. Cosine of 300 degrees, we'd be over here. That'd be a 60-degree reference angle in quadrant 4. The coordinates here would be 1/2 and negative root 3 over 2. I'm looking for cosine. It's 1/2. So cosine of 300 degrees is equal to 1/2. Okay, pause the video. Tangent of 330 degrees. So that's over here again. All right, the coordinates are going to be root 3 over 2, and negative 1/2. And I know that 30-degree reference angles, which is the tangent is root 3 over 3. But let's just prove that. So this is going to be negative 1/2 divided by root 3 over 2, which is the same thing as negative 1/2 times 2 divided by root 3, which is going to be 1 divided by root 3. It's negative, right? So then all we have to do is rationalize this. If we multiply it by root 3 over 3, sorry, root 3 divided by root 3, we will have root 3 over 3, and it's negative in that quadrant. There you go. Okay, cosine of 30 degrees. Cosine of 30 degrees is just right there. I know that these coordinates are root 3 over 2 and 1/2, and it's cosine, so the answer, the x value, is root 3 over 2. Tangent of 120 degrees. So 120 degrees is right over here. That's a 60-degree reference angle in quadrant 2. These coordinates are negative 1/2, comma, positive root 3 over 2. The y divided by x here is going to give me negative root 3 is the tangent of 120 degrees. To prove that, root 3 over 2, that's the y value, divided by the x value, negative 1/2, is going to be root 3 over 2 times negative 2 over 1. So that's just going to be negative root 3. Alright, last one here. So sine of 225 degrees, that's going to be down here. It's a 45-degree reference angle in quadrant 3. And I know that both the x and the y values are negative, and the x and y values are the same also. They're negative root 2 over 2, negative root 2 over 2. And I'm asked for sine specifically, so it'd be the y value, but cosine of 225 is also negative root 2 over 2. The answer, negative root 2 over 2. So this is the kind of thinking that you should kind of be doing. Visualize the angle in your head when it comes to evaluating the unit circle. There is more to it than this. We have 3 more trig ratios to talk about besides cosine and tangent, and we have a whole different way of quantifying angles, and it in many ways is a superior way, but we will get to that at a later time.